Okay, so section 9.4 talks about counting techniques and probability. So the first thing I have here is something called the counting principle, and it says if an experiment can be performed in m distinct ways, and a second experiment can be performed in n distinct ways, then the two experiments in that specific order can be performed in m times n distinct ways. All right, so let's take a look at the first example here. Let me scroll down a little bit, and it says, a password used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. Determine how many passwords are possible if, and it gives us a couple of scenarios. Okay, so let's do part A. So we're going to have 2 lowercase letters. Okay, so I'm going to go, this is my first letter, this is my second letter, and then 4 digits. There we go, 4 digits. Okay. So it says, if part A says, if repetition of letters and digits are permitted. Okay, so if we think about letters, we have 26 letters, right? In digits, there's going to be 10 digits, right? In case you're wondering, what are the digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are my 10 digits right there, okay? Obviously the letters are A, B, C, right, all the way to X, Y, and Z, okay? So repetition of letters and digits is permitted. So in my first spot, I can choose 26 letters. In my second spot, I can still choose another 26 letters because we can repeat the digits. The letters. So if I choose the letter A in my first spot, I can choose the letter A again. That's what it means by repetition is permitted. And then we have 10 digits to choose from, and we can still repeat the digits. So if I wanted to make this as my passcode, that would be possible. Okay, I could choose the letter A twice, and I could choose the digits 0, 0, and 0. Okay, so what I'm going to do now, guys, is I'm just going to take my calculator, and I'm going to multiply this out. So let me get my calculator coming up, and let me turn it on, clear it out. Okay, I'll move it over here. And so we're going to take 26 times another 26 times 10, 10, 10, and 10 again. And so my answer is 676 followed by 4 zeros. Okay, let's see. 676, 1, 2, 3, 4. So 6,760,000, right? Okay, let's do part B then. Part B says repetition of letters and digits is not permitted. Okay, so remember, we're going to have 2 letters, 1, 2, 3, 4 numbers. Okay. So for my letters, in the first spot, I have 26 letters to choose from. Because we're not going to be able to repeat them, now only have 25 letters to choose from. Okay. Digits, the first time I have 10 digits to choose from, but I cannot repeat them. So what does that mean? That if I use the digit 7, now I only have 9 digits to choose from. If I use the number 4, now I only have 8 digits to choose from. If I used a 0, now I only have 7 digits to choose from, okay? And again, I'm just going to multiply these out. So let me grab my calculator again. Let's clear it. I'm going to go 26 times 25 times 10 times 9 times 8 times 7. And I'm coming up with 3276 and then 3 zeros. So 3276, 1, 2, 3. So now we have 3,276,000, right? Okay. And now let's do part C. Okay. Remember, we're still going to have 2 letters, 1, 2, 3, 4 digits. Okay. So it says the first letter must be a vowel. Okay. So how many vowels do we have? We have 5 vowels. Okay. The first digit cannot be a 0, and repetition of letters and digits is not permitted. So I cannot repeat my letters and I cannot repeat my digits. Okay. So if I have to use a vowel, right? So suppose I used the letter O. Now, how many letters can I choose from? Well, I've already chosen one, so now I only have 25 letters to choose from, okay? The first digit cannot be a 0. That means I have 9 digits to choose from, right? And suppose I picked the number 7. Well, now I can use the number 0 if I wanted to, but I would still have 9 digits to choose from, right? Because I would have 0, 1, 2, 3, 4, 5, 6, 8, and 9. That's 9 digits, right? And then 8 and 7, right? Because we cannot repeat our digits. So now what I'm going to do, I'm going to grab my calculator again, and I'm just going to multiply. Let me clear it. So 5 times 25 times 9 times 9 times 8 times 7. And I'm coming up with 567,000. Okay, 567,000. Okay, there we go. All right. So let's take a look here. The next problem says the 8th grade class at a grade school has 10 girls and 11 boys. And how many different boy-girl dates can be arranged? Okay, 10 boys times 11 girls would give us 121. Right? Okay. So the next thing we have here is something called a permutation. It says a permutation is any ordered arrangement of a given set of objects, okay? And it says the permutation formula, the number of permutations possible when R objects are selected from N objects is found by this formula, okay? So here's my formula here, guys. And I'm going to show you how to do this on the calculator, so it's going to be really easy, breezy, cover girl, okay? So it says, in how many ways can a president, vice president, secretary, and treasurer be chosen from a club with 8 members? Okay, so the one thing that I want to mention about permutations, the order is important. What this means is that the first person that's chosen is going to be the president. The second person that's chosen will be vice president. The third one will be secretary, and the fourth one will be treasurer. And in that particular order. So if we pick, I'm going to make this up. I'm just going to make up some names. So suppose I have Mary, and I have Joe, and I have Rolando, and I have Amy. Okay? And these are just 4 names that I'm picking. If I pick Mary, and in that order, Joe, Rolando, and Amy, that means that Mary's the president, Joe's the vice president, Rolando's the secretary, Amy's the treasurer, right? But if I pick Amy, Mary, Rolando, and Joe, then that's a different order, right? So Amy's now president, Mary is now vice president, Rolando's still secretary, and Joe is the treasurer. So the order here is important, okay? This is when we know we're doing a permutation. So we have 8 members, and because the order is important, and we're going to choose how many positions we have? 4, right? So 8 permutation 4. Now, I'm not going to actually have to use my formula here, okay? What I'm going to do is I'm going to grab my calculator again. Okay, let me just move it over. I'm going to clear it. The first thing I'm going to do, I'm going to type in the number 8. So 8. I'm going to go to my math button. And if you notice right here, it says PRB, that's probability. So I'm going to go 1, 2, 3. There we go. Now I'm on probability. And I'm going to look for the PR. There it is. It's the second one. I'm going to choose that one. And I'm going to hit the number 4. Hit equals. And here's my answer. So 1680. Okay. All right. Now the next thing we have here is something called a combination. So a combination says it's a distinct group or set of objects without regard to their arrangement. So the order is not important. Okay. So it says Jackson has 16 books, but only has space for 7 on his shelf. He can't decide which books to place on the shelf, so he puts them all in a box, reaches in, and randomly selects 7 of them to go on a shelf. So part A says, is this a combination or a permutation? Okay. So if he's going to pick those 7 books, right, he's just putting them on a shelf. It's not like it doesn't say anything like the first book he puts on there is the first book he has to read, anything like that, right? So when he puts his books on there, right, 1, 2, 3, 4, 5, 6, 7, when he puts them on there, the order is not important, right? Because as long as the books are on the shelf, that's really what's important. So this would be a combination because the order is not important. Okay. Now, part B says, in how many ways can 7 books be selected out of 16? So since this is going to be a combination, guys, there's a formula that's going to look like this. 16 combination and 7. Okay. So again, I'm going to show you how to do this on my calculator. I'm going to bring it up. And let me just move it over here. Okay. So I'm going to type in 17. I'm going to go back to math. I want to get to my probability again. So again, I can hit this one. 1, 2, 3, right? By the way, guys, let me just clear this out again. If I want to get over here, I can hit it, the right arrow 3 times, or I can just go once to the left. And if you look at my NCR, because that's my combination formula, and I hit enter, and now the second number I want to hit is, oops, I was putting 17 at 16, right? Okay, let me start that again. 16, math, probability, combination, and we actually want 7. And so now I have 11,440. 11,440. Okay. There we go. Okay. So now, part A, or this next question, I'm sorry, says, assume a class has 24 members. And how many ways can a president, vice president, and a secretary be selected? Okay. Notice, these are specific positions. So this is going to be a permutation. The order is important. Okay. So we have 24 members, and we're going to choose 3 of them in which the order is important. Okay, so let me bring this up. So let's take a look. So we're going to go 24, math, permutation, and we want 3 because there's 3 distinct positions. So 12,144. Okay, 12,144. Now look at part B. Part B says how many committees of 7 people can be chosen? Okay, so 24. Now we're picking a committee, right? It doesn't say that these people have to be in a particular order, right? So when you put those 7 people, regardless of how you arrange them, they're still going to be on the committee, right? So this is going to be a combination. Okay, so grab my calculator again. Let's go 24, math, probability. This is a combination. We're choosing 7 folks. And so now I have 346,104. 346,104. Okay. All right. The next problem here says an ice cream parlor offers 36 different flavors of ice cream. Okay. One of the items is a bowl consisting of 3 scoops, each a different flavor. How many different bowls are possible? Okay, so let's think about this. You're going to get ice cream that's going to have 3 scoops. They're going to be different flavors. The way you can figure out, is this going to be, I think vanilla has 2 L's, isn't it? Sorry guys, I'm a little embarrassed here because I don't know if vanilla has 1 L or 2 L's, but aren't you glad I don't teach English? Strawberry and chocolate. Okay, so the question I would ask you to figure out, is it a permutation or is it a combination? Remember, permutation, the order is important. Combination, the order is not important. So the question I would ask is, if you have vanilla, strawberry, and chocolate, would that be different if you had first strawberry, chocolate, and then vanilla? Or if you had strawberry, vanilla, and chocolate? My question would be, are you still getting the 3 flavors? Yes, you are, right? So since the order is not important, this is going to be, again, a combination, right? So we're going to have 36, and we're going to choose 3, right? And so we're going to go 36, math, choose 3, and 7,140. Okay. So again, permutation would mean that these would all be different, right? Those would all be different. But you know, when you're eating a bowl of ice cream, it didn't really matter, right? It's not going to make a big difference. Or think about it, if you go to Stripes in the morning and you say, "Can I get a taco or papa con huevo?" And they said, "Well, I don't have papa con huevo, but I have huevo con papa." You would say that'd be okay, right? Because it's really the same thing. Yeah. Okay. So we have another little formula here, and it says the probability of an event happening at least once is going to be 1 minus the probability that it doesn't happen. Okay, so we're going to think about probability here. It says, from a group of 11 boys and 13 girls, a committee of 5 students is chosen at random. Okay, so before I even read part A, I want to think about this piece right here. Okay, I want to think of that piece right there. So how many kids do we have total? Total 11 boys and 13 girls would be, what, 24? So 24 kids, and we're going to choose 5, right? Okay, so because we're making a choice to choose these 5, they're just going to go on a committee. We're going to use a combination, okay? So when I'm dealing with probabilities, the easiest thing for me to do, remember, a probability is always going to be a fraction. The easiest thing for me to do, first off, is to do the denominator. So the denominator would say, well, look, we have a total of 24, and we're going to choose 5. So this is what my denominator would look like, okay? Now, I'm going to work on my numerator. When I work on my numerator, look at part A. It says, what's the probability that all 5 members on the committees are going to be girls? Well, how many girls are in this class? There's 13 of them. And we want to make sure that when we choose 5, all 5 come from those 13. So what I'm going to do now is I'm going to grab my calculator, okay? And I'm going to say, let's do the numerator first. Let's do the top part. 13 math. And we're going to choose 5. And that's going to give me 1287. And now I'm going to do my denominator, which will be 24 math. We're going to choose 5. Okay. Oops. 24 math. Choose 5. Okay. And this is giving me 42,504. 42,504. Okay, so now the next thing I need to figure out is how is it going to ask me to write this? I need to simplify this fraction, so it may ask me to write it as a decimal. In the event that it asks me to write it as a decimal, I'm just going to take 1287 and divide it by 42,504. Hit enter, and it'll tell you where to round. I'm going to go to 4 decimal places. So 030. Now that 2, because the number to the right of it is a 7, I'm going to bump that 2 up to a 3. So 0.0303. Okay. And I'm going to see if this will do it for me. Sometimes it will. If I hit this first one here, it'll convert my answer to a fraction. Now look, it reduced it to a fraction already in simplest terms. So 39 over 1288. So 39 over 1288. And you'll write whichever one it asks you to write. If it asks you to write a simplified fraction, then we'll write this one. If it tells me to write a decimal, then I'll write that one, okay? Now part B says, what's the probability that all 5 members are going to be boys? Okay, I'm going to do this almost the same way. My denominator is still going to be 24, choose 5. But now, because we want all of them to come from the boys, it's going to be 11, choose 5 at the top. Okay. So remember, we already know the bottom is 42504, because we did that bottom part earlier. Let's do the top part. What's 11, choose 5? 11, math, choose 5 is 462. Oops. 462. So let me go ahead and divide that out. 462 divided by 42,504. Okay. And if I go to 4 decimal places, 0.0109, 0.0109, and let me see if it'll reduce it to a fraction for me. So if I go math, convert my answer to a fraction, yep, 1 over 92. 1 over 92. And again, whichever way it asks you to write it, that's how you're going to write it. Okay, so now let's look at part C. It says, what's the probability that there's going to be at least one girl? So I want you to think about what at least one girl means. At least one girl means that there could be one girl, or 2 girls, or 3 girls, or 4 girls, or all 5, right? At least one means that there's one, if not more, okay? So the formula that we had right here that says the probability of an event happening at least once is 1 minus the probability that it does not happen. So what do I mean by that? Remember, these were all girls here. These were all boys, okay? So getting the probability of at least one girl will be equal to 1 minus the probability that there are, no girls, okay? Well, if there's no girls, that means that they're all what? They're all boys. So a couple of ways I can do this. 1 minus, and I can use my fraction form, 1 over 92, okay? Now I'm going to think about that 1 as 1 over 1 minus 1 over 92. 1 over 1 is the same thing as 92 over 92 minus 1 over 92, which would just be 91 over 92. And then if I wanted to convert that to a fraction, to a decimal, I would just say what's 91 divided by 92. And end up with 0.9891. 9891 as a decimal. 0.9891. 1, 2, there we go. Okay. All right, so take a look at the next problem here. It says, at the first Tri-City meeting, there were 8 people from town A, okay, 7 people from town B, 5 from town C. If the city council consists of 5 people, find the probability that 2 are from A, 2 are from B, 1 is from C. Okay, so let's do, this is similar to the problem that we just did. Let's figure out what's the total number of people we have. 8 and 7 is 15, and another 5 is 20. Okay? The city council is going to be chosen from 5. So we're going to choose 5. Okay, so remember, in doing these probabilities, the easiest thing is to do my denominator first. 20, we're going to choose 5. Okay? Now we're going to get into the specifics. We want 2 of them to come from A. Well, how many people come from A? 8. So 8 choose 2, okay, times we want 2 to come from B. How many came from B? 7. So 7 choose 2. And 5 come from C. How many do we want from C? Just 1. 5 choose 1. Okay. Now I want you to notice something. If I add these numbers here, I get this one. And if I add these numbers here, we get that one, okay? So let's do the denominator first. Let's go, what is 20, math, probability, choose 5, okay? 15,504. Okay, so let's write that down. 15,504. Okay. Now we're going to do the numerator. So I'm going to do the numerator like this. I'm going to put parentheses, okay? Because I'm going to multiply each of these things. 8, math, choose 2, times 7, math, choose 2, times 5 math, choose 1. Okay. And so I'm coming up with 2940 as my numerator. So 2940. Okay. Again, let's go ahead and see if we can't make that into a decimal. So let's see, 2940 divided by 15,504. Just divide it out, and I'm coming up with 0.1896, 0.1896. And I'm going to check to see if it's going to give it to me as a simplified fraction. Math, there's my fraction button. Yes, it did. 245 over 1292. 245 over 1292. And, yep, okay, we're done. Alrighty. So, let's take a look at this next one here. It's going to be done the same way, okay? Alright, it says, a committee of 3 people was selected at random from a set of consisting 8 teachers, 3 parents, and 7 alumni. Okay. So 8 teachers, 3 parents, 7 alumni. So again, I'm going to find the total number of people, right? 8 and 7 is 15. 15 and another 3 should be 18, right? Okay. We're going to choose 3. Okay, so let's do part A. Remember, it's always easy for me to do my denominator first. 18, choose 3. Okay. Now, part A says, what is the probability of the event that the committee consists of all teachers? Well, how many teachers are in this group? 8 of them. And we want to choose all 3 from that 8, right? Okay, so let's do it like this. I can even do this, guys, in one simple step. So how about if I do parentheses 8 math, choose 3 divided by 18 math, choose 3, and hit enter. And again, if I go to 4 decimal places, 0.0686. 0.0686. I'm going to check to see if it'll let me write it as a simplified fraction. So math, let's go to a fraction. Will it? 7 over 102. Perfect. 7 over 102. Okay. Let's do part B. It says, what's the probability of the event that the committee consists of no teachers? Okay. So I'm still going to do 18, choose 3 for my denominator. If we don't want to have any teachers, that means we're going to choose from the parents or the alumni. We're going to choose from that group of 10, right? So again, let's do it this way, and we'll say, I'll do it on the calculator exactly the way I did before. 10, math, probability. We're going to choose 3 of them, divided by 18, math, probability, and we're going to choose 3 of them as well. Enter. So to 4 decimal places, 0.1471, 0.1471, because that number after the 0 was a 5. Can I convert it to a fraction? Let's hope that we can. 5 out of 34. Perfect. 5 out of 34. Excellent. Okay. Let's move this back this way a little bit. And let's go to the next problem. Okay. Okay, so it says 2 coins are tossed. You win $8 if both coins are heads, and $9 if both coins are tails. It says you lose $8 if the coins do not match. What is the expected value of the game? And then it says, is this a fair game? So we'll talk about fair games in a minute, okay? So think about it this way. We're going to flip a coin and get heads or tails. And then we're going to flip a second coin, and we're going to flip that same coin again, and we're going to get heads or tails. So the first thing I'm going to do, I'm going to find my sample space. So I can get heads, 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 tails, tails, heads, or tails, tails. Okay. Now let's find our expected value. So remember, to find the expected value, the first thing I'm going to do is what's the probability that they're both heads? So remember, in my sample space, I have 4 possibilities. How many of them have both heads? 1. So 1/4 is my probability that I'm going to get both heads. And if I do that, I'm going to win $8. Okay. I'm going to win $9 if they're both tails. Well, what's the probability that they're both tails? Also 1/4. Now I'm going to win $9. Okay. I'm going to lose $8 if they don't match. Notice how many don't match? 2 out of the 4 don't match. And since I'm going to lose money, it's going to be a negative $8. Okay. Now I know I could have reduced this fraction, but I don't want to do that just yet. Okay. So look, I'm going to multiply straight across. I'll give you a hint. Look at the bottom. 4 times 1, 4 times 1, 4 times 1. Bottom's going to be 4. 1 times 8 is 8. 1 times 9 is 9. 2 times negative 8 is a minus 16. 8 and 9 gives me 17 minus 16 over 4th. So 1/4 is 0.25. Okay. So there's my expected value. Okay, we just found that. Now, we're going to talk about fair game. Okay. So the way we would figure out if the game is fair is if my expected value is equal to the cost to play. Now, when I come back to this problem, right, did I have to pay anything to play this game? No, I didn't, right? So the expected value, which is 0.25, is that equal to 0 because I didn't have to pay anything? No, it's not. So then we would say it is not a fair game. Okay. All right. So guys, for this last problem here, I'm going to show you this problem, and I'm going to do this on a calculator app so that you guys can see how I can do it. If you don't have like a TI calculator like the one that I've been using, I'm going to show you how to do this part on an app, okay? So the next problem here says, how many 5-card poker hands consisting of 3 aces and 2 kings are possible with an ordinary 52-card deck? Okay, so we're not doing a probability problem here. We're just trying to figure out how many 5-card poker hands can be made with 3 aces and 2 kings. Okay, so first thing we're going to do is we're going to figure out how many aces are in a deck of cards. Well, we have 4 aces, right? And we're going to choose 3 of them. Okay. Then we're going to say, how many kings are in a deck of cards? Well, we also have 4 kings, and we're going to choose 2 of them. Okay. So I'm going to do this on my calculator. Guys, I'm going to show you an app that I use, and I encourage you to use it because I think it's going to be pretty cheap. It's this one here called Graph and Calc 83. Okay, let me clear that out. So if you remember what I had before, I had 4. I'm going to go to math. I'm going to go to probability. I'm going to choose 3. Okay. If you notice, my cursor is real low, so I'm going to hit the little right arrow button, close my parentheses, and I'm going to go times, and I'm going to go 4, math, back to probability, and I'm going to choose 2. There we go. And I'm going to hit enter, and I'm coming up with 24. So right here, I'm just going to write in 24. And we're done.